You might be thinking why the drones are so efficient at moving so swiftly and how its speed and orientation is controlled. In first video of this series, we will see basic functionalities of MPU6050 sensor and how the sensor data can be read for the stability of drones. Let's jump onto the breakout board GY521 based on MPU6050 sensor. GY521 module is composed in a way that an Arduino board or any other development board can be connected to its serial interface. This allows the microcontroller to read data from the MPU6050. The MPU6050 is a popular sensor that combines a 3-axis gyroscope and a 3-axis accelerometer on a single chip. The 3-axis gyroscope measures the rate of rotation around each axis, and it provides data on the angular velocity of the sensor. The 3-axis accelerometer measures acceleration along each axis. It helps determine the orientation of the sensor with respect to the Earth's gravity. Let's visualize motion of a quadcopter in X, Y, and Z directions. MPU6050 sensor provides 6 degrees of freedom, the 3 rotational degrees of freedom, and 3 translation degrees of freedom. All this sensor data is processed by another module inside MPU6050 called Digital Motion Processor. In other words, Digital Motion Processor offloads complex motion processing tasks from the main controller and provides the motion data to the controller over serial interface. Let's take a look at the pins and working principles of MPU6050 sensor. The breakout board of MPU6050 has 8 pins that can be connected to the Arduino. By the way, we need only 4 pins to get the sensor data. These 2 pins are needed to supply the power to the MPU6050 sensor. Next 2 pins are dedicated for I2C serial communication, and these pins send the sensor data to the controller. Next 2 pins are used for auxiliary I2C serial interface for communicating to an off-chip sensor data. The last 2 pins we can ignore at this point. Let's go through the MPU6050 architecture. Inside the sensor, each axis of accelerometer and gyroscope has a separate block containing their respective data. This data gets converted to digital data from analog. After sensor data conditioning, each data is saved in sensor register and it is ready to transmit over the I2C serial interface. I2C interface uses just 2 lines to transmit the data. One line to sync the clock between master and slave data, and the second line to transmit actual data. And here is a complete setup of MPU6050 breakout board and Arduino. Let's check out some application in different fields due to its ability to provide accurate motion sensing and orientation data. Drones and quadcopters use the MPU6050 for stability and navigation. The sensor provides real-time information about drone's orientation, allowing for precise control and stabilization. MPU6050 contains an accelerometer and gyroscope, which are essential for measuring the robot's orientation and detecting tilt and acceleration. These readings are crucial for the self-balancing functionalities. A humanoid robot also needs its orientation and detection of its tilt along with the acceleration. MPU6050 can provide all this information with accuracy and low latency. This is the first part of MPU6050 sensor video. In second part, you will learn in detail how to connect MPU6050 breakout board with Arduino. We will learn how to read sensor data of accelerometer and gyroscope and how to calibrate the sensor data. Stay tuned if you want to learn more about similar topics. If you like this video, subscribe my channel, hit the like button and don't forget to press the bell icon. Thank you.